In this clip, we explore the idea that the annihilator is the dualization of the null space. So let's look at the null space of the dual of T. To kick things off, we've got Theorem 3.107. So this states that for a couple of finite dimensional vector spaces, and a linear map between them, we have that the null space of T prime is actually the annihilator of the range of T. And we also have that the dimension of the null space of T prime can be computed as the nullity of T plus the dimension of W minus the dimension of V. And if you smell the rank nullity theorem, you're not wrong. Okay, so let's look at the proof. So for part A, here we've got, let's see, so if we're looking at the null space of T prime, so we'll take phi to be in the null space of T prime, and that's going to be true if and only if T prime of phi is the zero map, meaning that phi of T is the zero map. And so that means then that phi composed with T applied to any vector is going to be 0. But that's the same thing as phi applied to TV being 0. And so this last one here, if we just focus on this part right here, that's saying that the range of T, because that's what something that looks like TV, that's something that's in the range of T. The range of T is apparently in the null space of phi. Okay, I guess I don't need that other double arrow. Got carried away. Okay. So this is, well, okay, here. No, you know what? Fine. We'll do that. Because this is what it means here for phi to be in the annihilator of the range. There we go. All right. Cool. Let's look at part B. So for part B, actually, you know what? Let's not look at part B. First, let's draw a picture. So, and I don't know if this is a helpful picture at all. Maybe it's a dumb picture, but here's the idea. So if we look at T and then we dualize to get T prime, well, let's see. We could, on the one hand, take the range, and so this is looking at the image. And then on the other hand, well, actually, you know what? Let me just call it by the same name, range. And then on the other hand, we can do sort of the opposite thing, which is take the null space and get the null space of T prime. Then it turns out that this is the same thing as if we dualize the range and look at its annihilator. So there's all kinds of things to look at in this picture. For instance, you can see that the range and the null space are playing the sort of inside out dual roles of each other. And you can also make observations like basically what we're looking at on the one side of this equation. So where we've got so on this equation right here is on the one side we've got things that so you're on the left if you kill the output of T, and you're on the right if you are an input killed by T prime. Okay, something to think about. I don't know if that was super necessary, but anyways. Now let's think about part B. So this, so we're looking at the nullity here. So the nullity of T prime is the, by definition, dimension of the range of, sorry, not by definition, but by part A, it's going to be the dimension of the annihilator of range T. And then if we look at 106 from this chapter, this is the dimension of W minus the dimension of the range of T so here I've got V equal to U in that theorem, and U equal to, oh sorry, W, V equal to W, and U equal the range of T. And this is the dimension of W minus, then we've got dimension of V minus nullity of T by the rank nullity theorem. Okay, and that gives us the result. Fair enough. And as a parting shot, we've got a corollary, and that is that T is surjective if and only if T prime is injective. All right, and so the proof for that, with all we've got, is actually pretty straightforward. So a linear map from V to W is going to be surjective if and only if its range is the entire codomain, just by definition. And that's going to be true if and only if the range of the annihilator of the range of T is equal to 0. And this is one that we discussed before with the old switcheroo. So this is the idea that phi is going to be in the annihilator of the range of T if and only if phi of W is equal to 0 for all W, right? So now we have on the left side the null space of T prime by their previous result, and then this is equal to 0. And then that's exactly the statement that T prime is injective according to some theorem we did oh so long ago.